Hello and welcome. Today we're going to learn about rules for exponents. So this involves problems where you have to deal with variables or numbers with exponents. For example, x squared times x cubed, or 3 to the fifth over 3 squared, things like that. Now the way these exponents interact with each other is pretty unique. And I've developed a little system that can make it a lot easier for you to understand it. So the system goes as follows. At the bottom are the first two operations you ever learn in math. So think about the first two things you learn in math, and you should think about adding and subtracting. After that, you're going to think about the next things you learn in math, next two operations. One step above that would be multiplying and dividing, right? They're opposites of each other. After that, what comes after multiplying? What's a more complicated version of multiplying? Well, that's going to be squaring, or any other exponent, and square rooting. And this is what I'm going to call the power tower, right? So this is what's going to hold it all together for us. Let me show you how it works. So if I have, for example, the x squared times x cubed right here, I'm going to combine these, and I'm thinking, what am I going to do? What am I going to do? Well, let's think about what's happening between the bases. They both have a base of x, and the way they're interacting is via multiplication. So I'm going to go over to this power tower and think, multiplication, what's one step below that? Addition. So when I combine these expressions, I'm going to get x to the power of 2 plus 3. I step down and perform the operation on the exponent. Notice those two bases combine into 1, and that ends up being x to the fifth. Over here in this example, we have 3 to the fifth over 3 squared. Well, that's division, so I'm going to go back to my power tower. I'm going to think, division between the bases, right? 3 and 3 are being divided. I step one layer down. Oh, a subtraction. So I'm going to keep the same base of 3, and it's going to be the power of 5 minus 2. Because I step down, I'm doing subtraction. Ends up being 3 to the power of 3. Now, let's get some more examples going. What if I have something like a to the third to the fourth power? I have this exponent. What am I going to do? What am I going to do? Well, all I'm going to do is go back to my power tower and reference this and say, what happens if I have exponents? Well, as I can see here, I can step one layer down, and I'm going to multiply those together, right? Stepping down from the exponent to multiplication, the simpler version of it. So that's going to leave us with a to the 3 times 4. Once again, the base simply sticks around, and then you mess with the exponents according to this power tower. And that is going to give you a value of a to the 12, and that's your answer. Let's say we have a cube root of x to the sixth power. Now, what am I going to do between these? Well, once again, I'm going to go over to my power tower, and I'm going to find the operation that's happening. In this case, I see I have a square rooting happening of my exponent, square rooting. So what I'm going to do is step down one layer, and I'm going to do the division sign that's below it. And so when I do this, I'm going to get the same exponent, x, to the power of, and I'm going to divide. This is a little strange looking. The power of the radical is what's in the denominator. So I'm going to put a 3 down here, and the power of the regular exponent is on top, x to the 6 thirds, which is going to be equal to x squared. That's your answer.